are now recording part 3. We're going to continue with Excel and recreate this titration curve without having to take into account the regions. So you should have just watched part 2 where we talked about it, and now we'll do it. So I'm going to create a new sheet. I renamed this one regions, and this is just going to be with no regions. So just strong acid, strong base. Okay, and let's see. We're basically going to start out. We can copy all of this over. That's going to be the same. And also, I want to copy the columns. Okay. And we'll start with just a few different values of acid added. I guess I probably could have copied some of this too. This will equal volume added plus the initial volume. That doesn't change from before. Okay, what else doesn't change? Moles added doesn't change. But now the moles of OH minus unreacted does change. Okay, so here is where we're going to start applying what we just did. So notice here we have if statements. And the nice thing is here it shows everything that we should have as inputs here. So here's the logical test. And so remember what the logical test is. It's the question of the moles of OH minus initially, is it greater than the moles of H plus that's added? I'm going to add my $sign here, okay, and then a comma, and now you see it highlights onto the next. So here's where we're going to put the value if true. Okay, so if it's true, then we refer back to what we had written before, right? Then it's going to equal moles of OH minus initially minus the moles added. And I'm going to go back again and put a $sign. And if it's false, what does it equal? It equals 0. And then we can close the brackets. Excuse me. Sorry. Okay. Concentration of OH minus will be the same as before. It's going to equal moles divided by volume times 1,000. And now we have another if statement. Another conditional statement. So it equals if, and our logical test is the same as before. Right? If the moles of OH minus minus the moles of H plus added, sorry, not minus, is if it's greater than, then if true, it's 0, and if false, then I want the moles of H plus added minus moles of OH minus initial. And close brackets. And it gives me 0. That's what I want, right? Because there is no H plus excess yet. And the concentration of H plus, even though it's 0, we can still figure out that it's going to be equal to moles divided by volume times 1,000. And pH. Okay, here's the fun one, right? Because we have this is what you call, it's a nested conditional statement, because there's an if statement inside the if. So let's see if we can make some sense of this. Actually, it'd be awesome. You should pause it and try to do this on your own first, based on the last video. Figure out what the logic is going to be. Okay, so if, what's our logical test? If the moles of OH minus is positive, so if it's greater than 0, then the pH will equal 14 plus log 10 of the concentration of OH minus. If it's false, then I have another if statement. If false, then if moles of H plus excess is greater than 0, then pH is equal to the negative log 10 of concentration of H plus, or else it's equal to 7. And we're going to close the whole thing, and there's a typo. Oops, I can't see it. Oh, I forgot another bracket on the end. So I think everything was good. I just forgot to close. I closed this if statement, and then I needed one more bracket, one more parentheses to close the outer if statement. And so that should be it. And you can see it's kind of color coded here. So I should have known when I hit this one that the two red ones line up, and then that would complete it. So I get the same answer as before, so that's good. And we can format the 2 decimal places. Okay. So now that we have, I think, taken care of the regions, right? And we don't need them, don't care about them anymore. We can just go ahead and fill in column D, and then one drag down, and we should be done. Okay, you ready to try it? Let's see. Oh no. Oh, I forgot. Same problem I did last time. I forgot to do $sign. Dang it. All that, and then, yep, errors happen quite a bit. So the dollar, remember again, the $sign I forgot was on concentration here. So $9. I think the rest of these. Oh, that should have. I have one there too. So anytime there's something in A, it should have a $sign. Yeah. Okay, that's true. Now we'll try it and see if we get it. Nope, another mistake. What's the mistake here? Can you find my mistake before I do? it's kind of hard with this error in the way. Okay, I found my mistake, I think. Yeah, I put as my very initial condition moles of OH minus greater than 0, but that's not right because it always is. I don't want moles of OH minus initial. I want moles of OH minus unreacted. So not A5, not A5. Should be G2, right? If moles of OH minus unreacted is greater than 0, then the pH is equal to 14 plus log of the concentration of OH minus. Or else, if the moles of H plus excess is greater than 0, pH is equal to the negative log of concentration of H plus, or else it's equal to 7. That looks better. Let's try it again. Yeah. We all make mistakes. That's actually part of the learning process. If it all works the first time, then you don't know how to find problems. So maybe you solved it before I did, but if we compare this to what we had before now, it's totally the same, and so that's cool. Let's see. Put a plot, and it should be the same. This time I'm not going to bother with details of it. We can see we get the same plot. So another thing that's nice here is that if the problem changes, our spreadsheet is still good, right? If we go back to where we have different regions, and we wanted to, if we change the volume of, say, the base that we started with, or we change the concentration of the base, or even we change the titrant, any one of those would change the equivalence point, and all of the regions, where the regions split would be different, right? Can you see the problem? If we change this to, let's say 40 milliliters, then we run into a huge problem here, right? Because now the equivalence point is at 8, and we would have to redo everything to fix that. But here, if we change it to 40, everything still works. The thing is now, right, we'd want to zoom in and add some points around 8, but we can see that nothing's wrong. We just need a little more precision there, and all these points here don't really mean much. But because we set it up this way, it's easy to change the plot or to change the problem without having to redo everything. So if we double the concentration of the titrant, it all still works. We just lose some precision, and we'd want to go back and add some points closer to that. But that's part of the power of this approach here, and that's kind of what we want. You'd want to be able to change your spreadsheet or change the problem and get the result easy without having to redo everything. So if you want to play around with this some more, those are try changing any of these right here. You can change those and watch things happen. And you can also change then the volumes added if you wanted to add points between the points, or find if you have a new equivalence point, zoom in on that, then you get your better curve. there you go. Okay, so I think that's it for this time. And so next time we'll start looking at what happens if not strong and strong, but weak and strong. So if you have a weak acid and a strong base, for example, there are 4 regions we have to consider. And then there are also other ways that we can use spreadsheets to help make this easier. We'll get to that as we go ahead. So we'll end here for now. All right, bye-bye.